Okay, good morning, everyone. So here's our final exercise for FRM 149, or geospatial methods in forestry. So the last exercise will be on delineation of watershed areas using QGIS. So what are the input files that you need to delineate watershed areas? So you can check in your LMS and click the link to download the data resources. On the data, you can find um, three folders. Now we have the shape files, we have the base map, and we have a raster file, which is a DEM. So to start the tutorial, so kindly follow the link, follow this video that I have recorded earlier. I just make the sound. No? Okay, this was already recorded last semester, so I will just show it and then provide a narration of the different activities. So first is you have to load your data. So on your data folder, you have a DEM file. Load the DEM file and check the CRS on the properties. So on the general, you'll find that the CRS used was WGS84. So we have to reproject this one into a WGS84 UTM zone 51N. But before that, I have to post this one. You have to set your project properties CRS into WGS84. So I have to go back here. Here on your project properties, you have to enable on-the-fly CRS transformation. You click this one and select UTM zone 51 and apply. And then once applied, let's go back to what we left. You save our DEM as a reprojected. So from WGS84, we set the target into UTM zone 51N. So this will be in meters now. Processing completed, okay, and close the application. Then we can now remove the original DEM file. And then let's check the properties. Now it's already UTM zone 51N. And change the symbology, load the minimum maximum values. So it changed from negative to negative 36 and 1748. So this is now our reprojected DEM. So after that, we will J-reference our, say, base map. Well, actually, we already have previous activity on J-referencing. So this is just to refresh you of using of J-referencing PDF files that was downloaded, especially kanang mga topographic maps that is downloaded from NAMRIA website. And on the transformation, we set is as WGS84 because the projections of downloaded base map is WGS84. So it's WGS84. Then the output transfer, we rename it as modified and save it on our outputs folder. Okay, click OK, and then we can now add the points. Now, the difference between WGS84 and WGS UTM zone 51 is that the coordinates are expressed in degrees, minutes, and seconds for WGS84, whereas for the UTM, it's in meters. Now let's add the different points. This is the corner with 125 easting, 125 space 2045. Then the northing is 9, 20, and 00. Okay. And continue on the other corners. Okay, and then the last corner. Okay, so I think all corners were already georeferenced. So next step will be to run the georeferencer. And after it's done, you can now minimize or close and check if it's aligned with our DEM. So it looks like it's already aligned now. Just looking at the corners. So here, so to expedite the process of say classification later, so we have to clip our image to the extent of our base map para paspas siya or dali lang siya i-process, because we have to process. There will be a lot of processes later on, especially if we are going to delineate our watershed already. So here we clip our DEM to the extent of our base map. So we can now hide the original DEM. And what remains will be our clip DEM. It's either you can delete or not, you can remove or just hide the the reprojected DEM. Next step is to change the symbology of the clip DEM. Then we open the toolbox in our processing. Then next will be on to search for the fill sinks by Wang and Liu. So this fill sinks is an algorithm that fills on the sinks of your DEM so that you can have a continuous flow of the water, no? Especially if kung mag-ulan siya, so the water will find a way from one point towards its surrounding 9 points. So na siya agianan. So it fills the sinks para dili siya ma stagnant or mabilin dia sa tunga. So it's processing. The resulting raster will be the field raster. So now we have our field DEM. We can now remove and leave our DEM. Then let's change the symbology. Again, don't forget to load the min-max values. Click apply and okay. So we now have a field DEM or digital elevation model. Next thing to do will be to search for the channel and the network. Search for this one, channel, network, and the drainage basins. Then the elevation we are going to use is our field DEM. Then we can uncheck some, uncheck connectivity, stroller order, basins, because we have a separate algorithm for basins. So we'll only leave this at one. processing, not responding. Okay, it's done, I think. So we now have the channels or the network of the streams and rivers. So these are uh, line vector files that symbolizes the to where the water will flow during precipitation or rainy seasons. So these are also the network of the streams and the rivers. Okay, then we open our plugins and search for capture, the coordinate capture. If it's not yet installed, you have to install the plugin and then load it on our panel. So this one. So once you click, the coordinates of that pixel or location will be copied on this one. So start our coordinate capture and see to it that it's along the line, along that this line should be the outlet of a watershed. So kanang baba kung asa siya mo ano kanang di siya mo drain. Then having captured the coordinate, we search for an upslope area and paste our x and y coordinates. Then we will paste this one, kinesia, which is a grid coordinate and not this WGS 84 or expressed in decimal degrees coordinate. So let's paste and then remove some of the other coordinates, because once you copied, all of these informations will be copied in your temporary memory, and then once you paste it, all of this information will be pasted also. Change your elevation into the field DEM. Then leave everything by default. Click run. And wait for it to process. Sometimes now, if your coordinate is not really aligned with the line or with the outlet of your watershed, it will give you a different value. So here you have already two values for our raster file for the upslope area, 0 and 99. Then if you have two values, skin and white, this is the outline or the boundary of our watershed. The next thing to do is we have to change that one, convert this one into a vector file because this is an image file. Then save that file. Say this is the boundary of the Santiago watershed, or it is located in Hagupit. Save. Okay. Wait for it to finish processing, and I think it's completed already. So here you can see that there is a Santiago watershed added in our table of contents. So let's check the attributes. We have values 0 and 100. So you click that, which is 100 is the boundary and 0 are the extent of the base map. So we will remove the 0. Para ang mabilin is only the watershed boundary. So now we have our watershed. Okay. Then we will add some attributes in our watershed. Again, we have already done this exercise by adding attributes or adding fields in our existing vector file. So first we will add the area. Area is in decimal number or real. Then search for the geometry and the string area. divided by 10,000 so that our area will be in hectares. Then automatically it's computed on our vector file, save, and then close our vector file. Okay, we can now remove our upslope area. It's no longer needed. And then with our DEM, we can clip the portion of our field DEM based on the initia, based on the boundary, generated on our vector file, the Santiago watershed. First, let's change some symbology. And then on the outline, and then the fill, let's set it as transparent. Change the width of our outline or the line, say 0.4. Okay, click apply, and what remains will be the boundary of our small watershed. Okay, let's check if it coincides with our base map. Geoprocessing tool. And then, so here we will be clipping the field DM to the extent, to the boundaries of our Santiago watershed. Sometimes when you do clipping using this tools, it yields an error. So we have to search for other tools in our processing tool. And I think that the polygon clipping of Saga is good. No? Doesn't have a bug, so it can be used for clipping our say field DEM. Okay, it's processing. Now we clip the say the stream network that are inside our watershed. So we can now remove the channels. And then what remains will be the stream network that is inside our watershed. That's polygon clipping. Polygon is a vector file. So next thing to clip is the raster clipper. Field DM will be our input file. Output file, we save it as the clip or samande field clip. Save. And then we will use a mask layer, which is the boundary of our watershed, a vector file. Click OK, and it's processed. So we now have a clip DM. You can change the symbology. Again, don't forget to load the main max values. Apply. And OK. We can now remove our field DM. Then let's change the color of our stream to darker blue so that it can be visible during presentation. Increase the width 0.3. Okay, and see, looks good. And on the properties, we can set our transparency into say 60% because we will be using an XY Z tiles later. So we add the XYZ tiles. It's the terrain. From the tile silver, we create new connection and then copy the link. that is presented in our LMS. So XYZ link, this one, you can copy this one and paste on our new connection. Paste and then click OK. Enter whatever we try to name that tile. For me, I just name it as terrain. Then click terrain. Okay, let's go back to our layers panel. And then drag that terrain downstairs. So we'll have our boundary on top. I mean, our watershed on top of the terrain. Then we will load the vector files. The Agusan on our data. We have here the shapefile for Agusan del Norte. So this is a shape file for the municipalities within Agusan del Norte. So let's change the symbology so that we can see what's below. Set it to transparent and then the outline will be white, or depending on your, because you're an artist and mapping is an art, so you can choose whatever colors that suits your sense of being an artist. You add labels for the municipality, then draw buffer so that it can be visible. Increase the font size, click apply, and it's okay. Click OK and apply. So I think the map is more or less ready for layouting. Next step is to lay out our map so that we can save it as a JPEG file or an image file. So on an empty map, you drag by adding the map. Then resize, reposition our watershed by changing the scale of the map. Let's try, say, change the scale to 70,000. Let's try. I think it's okay. Or adjust a bit to 80,000. So it will be smaller. 100,000. Lock layers and lock extend for the layers. And then we add the grids. Frames and annotations only, and then we select WGS 84. For the intervals, set 0.05. Then for the frame, we can use zebra or interior ticks, exterior ticks, whatever. For me, I select zebra. Then draw the coordinates. So the coordinates are expressed in degree and minutes. Then I decrease the precision into 0 so that what remains will be the degree and minutes na unit. Let's try this one. Okay, I think it's okay. So let's change it into degree minute second with suffix. And then configure the placement of our the coordinates. So our watershed is a bit small, so I think we have to increase the scale. Say 90,000. Sige, pwede. Then we add some elements. First will be the label or the title or the name of the map. It's a map of the Asiga watershed. So that watershed down in located in Santiago or Hagupit is exits on the Asiga River. So they call it as Asiga watershed. And center, middle, whatever. And we add a frame if we want. Or pwede walay frame, you add background or pwede walay background. So it depends on your liking. No? So as I have said, mapping is an art. So you provide details, you provide elements that will be pleasant para pagtanaw o nindot ang mapa. But it's up to you as the creator or the maker of that map. You add the north arrow, no? Basically to orient our map towards the cardinal direction. And then let's check some of the outputs already. What are the other elements that can be added? So ito ganina, we add the information. Here we provide information on the CRS used. So WGS 84, CTM zone 51, and the area. Let's look our shapefile that we computed earlier. It says 885 to 8500. Paste, copy that one and paste here. 8,528, then hectares. Location, so as ang location niya, which barangay or which municipality. So it's in Santiago, Agusan del Norte. Then the scale used is, kanina 1 is to 90,000. Okay, then we will siguro increase or change the font to 12. Then reposition our information pangit. Kilas-kilid lang. Okay. This one is aligned with the information. So if you see, as you move the element, there will be grid lines, no, or guidelines that will show. Pwede ninyo magamit to align one element to the other element. Next thing is to save our, okay na to, let's save our work into a JPEG format. Then rename it as Watershed, then with your family name. Resolution, so leave it as is, 300, so that we can conserve by a file size for submission. So the lower is our DPI, the lower will be the memory or the file size used. Let's check our work if it's okay. And so map of the Asiga watershed. So I think everything is in order. So that's it for our, okay. So that's it for our final, oops, this one. Okay. So again, if you have questions, you can send direct message to my messenger account. But again, as constant reminder, refrain from chatting or sending message that is already late in the evening. or that's beyond 9 o'clock. Okay, hindi na ako mag-reply. So good luck everyone, and hope you will be able to finish all the activities on the time allotted. So all exercises will be due on June 10, 2022. So kana siya tanan activities no from exercise 1 to 10. So siguro I will open exercise 1 up to 10 so that for those who were not able to submit the activities from exercise 1, you still have chance to submit on the last date, June 10, 2022. And then as a reminder again that I constantly remind everyone that the work you submit will be your own work. No, dili siya copy pasted from the works of your classmates, because I will know which work is copied and which work was done by you. No. I have an application that will trace, that will look into the metadata of the file you sent me. So tanaw na ako sa metadata if it has the same information from the other submissions, then that means they are created as one. Kaisa rin na buhat ana. And then we change ang name lang, change ang time, change something. So mahibaw na ko na. So make sure nga ikaw ang gabuhat gyud sa tanan activities. Kay in the event nga I will find out nga dili ikaw ang gabuhat or you simply copied everything. So wala na kay chance, no? Wala na kay chance nga mo submit again kay deadline naman sa June 10, and I will no longer accept submissions beyond that date. Kay di na maapas, no? So by early next week, I will start checking your activities from 1 to 10 and make sure again that you submitted all requirements, all of the exercises that we have for the semester. Then we still have mga dua ka quiz. I will post later or tomorrow and next week. And then one final exam on the scheduled examination week. So that will be for siguro parang nasa tanan, no? As a reminder. So thank you and hope you learned something from our course. This is just basic QGIS. Basic GIS operation. So mga basic lang na siya. If you are planning to be to learn more on GIS, we will have an advanced course for GIS analysis. So that involves mga remote sensing of data, image classification, then we can have modeling, etc. But that will be later na siguro. So that's it. Thank you. And once again, good morning, everyone. Stop recording.